today's video, we are going to talk about what is meant by ground state and excited state, and what this has to do with electron configurations and the structure of the atom. So first thing is that ground state is going to be normal. So when you have a question that says, what is the ground state electron configuration for aluminum? All you do is go to the periodic table, look up aluminum. Aluminum's electron configuration is 2, 8, 3. So that would be what it is in the ground state. What the ground state means is that electrons are in the lowest available energy levels and or sublevels. It's going to be how it's written on the periodic table. So it's going to be its normal configuration, and energetically it will be stable. When something is in the excited state, that means that it has extra energy. So just like if you're excited, you have extra energy. When the electrons or electron is in the excited state, it means that the electron has gained energy, which then causes the electron to move out to a higher energy state. So that would be the excited state. And that is unstable. So when an electron gains energy, then it moves out to a higher energy level. That is unstable. So again, aluminum. Aluminum in the ground state its electron configuration is 2, 8, 3. So that is its normal electron configuration. So there's normally 2 electrons in the first shell, 8 in the second, 3 in the third. If aluminum becomes excited, what happens is it has gained energy. So that could be from heat or from light. One or more electrons bumps out to a higher energy level. So aluminum excited might be 2, 8, 2, 1. So there's still 13 electrons, but 1 electron has moved from the third shell out to the previously vacant fourth shell. Or, the electron configuration might even look like, say, 2, 7, 4. In this case, 1 electron has moved from the second shell out to the third shell. But it's really more likely that it's one of the valence electrons that moves. So you keep the same number of electrons, but an electron bumps out to a higher energy level. Because this is unstable, it does not stay this way long, and it will return back to the ground state. When the electron returns back to the lower level, it will release the energy that it had previously absorbed. So again, the excited state is unstable. So it won't stay that way long, and the electron will return back to the ground state. Energy will be released. Often it is given off in the form of light. So depending on the amount of energy that's released, that will correspond with a different wavelength of light. Different wavelengths correspond with different colors on the visible spectrum. So the wavelength or color of the light is going to be unique to the element. Therefore, it can be used to help identify the element. All right, so we've got an example here. First example, what is the electron configuration of an atom of sulfur in the ground state? So ground state means normal. So we literally just go to the periodic table and we copy down sulfur's electron configuration. So that would be 2, 8, 6. So 16 electrons total, 2 electrons in the first shell, 8 in the second shell, and 6 in the third shell. What is a possible, so you could have more than one correct answer for this, electron configuration for an atom of sulfur in the excited state? So when an atom is excited, it has gained energy. One or more electrons have bumped out to a higher energy level. So one possibility would be 2, 8, 5, 1. In this case, one of the valence electrons have bumped out to a higher energy level. So one of the valence electrons moved out to the previously unfilled fourth energy level. And you could give a bunch of different examples of possible electron configurations. So you could do 2, 7, 7. So here you would be taking an electron that had been in the second level, moving it out to the third. You could even technically move 2 electrons. So you could do 2, 8, 4, 2. So you still have to have a total of 16 electrons because that's how many a sulfur atom would have. And you can't violate any rules. So what I mean by that is we can't do 1, 9, 6. So that one doesn't work because the second level can only hold 8 electrons. So as long as you don't violate any rules, if you were answering this and listing a possible electron configuration for it to be excited, you could technically have a lot of different answers. But again, same number of electrons, move one or more out to a higher energy level.